Today we're going to be looking at when exponents are ones and zeros. The way I like to explain it is through the division of exponents. So if you have any questions about how to divide exponents, go ahead and see my previous videos on dividing exponents. So I want to look at what happens when we divide an exponent here. So here I've got 3 to the 5th power divided by 3 to the 4th power. Now there's two ways to do this. We can actually write all of these out. So I got 5 threes. So I go 3 times 3 times 3 times 3 times 3. So I've got 5 threes here. And now I happen to have 4 threes here. 1, 2, 3, 4. And then I can go ahead and just cancel them out. And that gets canceled. A 3 on the top, 3 on the bottom, top, bottom, top, bottom. So now I'm just left with a 3. Because that's all 3 over 1, and that's simply 3. Or the shortcut that we learned when we divide these is we can actually keep the base the same, take this top exponent, make it a 5, take the bottom exponent, and we're going to subtract it. So 3 to the 5th power is 3 to the 1st power. This comes from the exact problem, 3 raised to the 5th power over 3 to the 4th power, and we get 3 to the 1st, or we get the number 3. So 3 to the 1st power is equal to the number 3. Now, since the bases are the same, it doesn't matter what base we have in here. So that's where we come with our general rule that states a to the 1st power, or any number, any letter. I mean, I could have like a smiley face to the 1st power. That's just going to equal smiley face. So it doesn't matter. Whatever it is, anything to the 1st power is itself, is whatever that base is. So if I do 75 to the 1st power, that's simply 75. Or another way we can go backwards, if I have the number 22, that's also 22 to the 1st power. But what happens if it's 0? I want to use division to describe that again. So here I have 3/5, or 3 to the 5th power, divided by 3 to the 5th power. Now we can go ahead and right up here, we can write 3 times 3. I'm going to write that 5 times, all divided by 3 times 3 times 3 times 3 times 3. So all these here will cancel each other out. I got that 3's gone, that 3's gone. So they all keep canceling each other out. So if that's true, then what is left over? Well, that just happens to be a 1. That's all that's left over. And we can see this when we actually take any number. If I do 25 divided by 25, that's simply just 1. Any number divided by itself is 1. If I do x divided by x, that just equals 1. It doesn't matter if I use numbers or variables or anything else. And we can see here I have the same number, 3 to the 5th power over 3 to the 5th power. It's going to equal 1. But if we use the shortcut for the division property, we take the 3, which is our base, take the top number, or top exponent, which is 5, and I'm going to subtract it from the bottom exponent. So 3 raised to the 5 minus 5 power is 3 to the 0 power. So similarly, when we did the exponent of 1, we have 3 different ways that we can actually get the exact same answer. So 3 to the 0 power is equivalent to 1. And so if we look at this, it doesn't matter if we have a 3, a 5, or a 10, or anything. That leads us to our general statement of when we have a to the 0 power, or anything raised to the 0 power, it's simply equal to 1. So if I have x to the 0 power, that equals 1. If I have 17 to the 0 power, that equals 1. Anything to the 0 power is 1.